Hello friends, in this particular video I will be demonstrating the execution of BERT, which is been developed by Google, and it is one of the very modern approach in context to natural language processing. Well, BERT actually is a deep learning model, and it can understand the context of word by looking from both left and right, and that's the reason why the letter B stands for bidirectional. And it also has got the concept of transformer. That's the reason why the letter T stands for transformer, whereby the model can work on neural network, and for that reason it needs either PyTorch or TensorFlow that will generate this particular neural network where the BERT can actually work. In this particular video I will be making use of PyTorch, and with the help of PyTorch the BERT can develop the neural network and can run the model, and we'll see that in fact in action. Well, before we start the execution of this particular program, the first thing what we must remember is that we have to download three important concepts, and associated with that there will be multiple files. One is called Tokenizer, and I have given a simple example of the Tokenizer concept over here. So what these Tokenizer files will do? Well, it will be responsible for converting the text to numbers. And what do I mean by that? What I mean is that, just a second, yeah, what I meant by that is, like, suppose I have taken a sentence like I love this movie, right? So each of this letter will get a numeric value, like what you can see right over here. I stands for 2023, love stands for 2003. In this way it will go on. Well, the first and the last character there will be extra numeric value context to first and the last characters. I mean the last word, you can say. So at the starting there will be a numeric representation, at the end also there will be a numeric representation. So that's how the ID comes in pictures, and later on these IDs will be all converted into further more numeric values, which we will be seeing it. So that's what the part of the tokenizer concept is all about. Next, what we need is a model file. Well, it's a tool that will convert the number into prediction. That's what I was saying, that these numbers now need to be converted into prediction, and for that reason we need the model file, and it has to go through a series of steps that will come right over here. So basically the model is converting the number into a meaningful probability so that it can go for the prediction, and that's what the model file is all about. And finally it needs some data set on basis of which it will be working on. Well, in this particular video I have used the IMDB dataset, but you can use other dataset as well. Okay, so that will be also required to be downloaded, and that dataset has got the text as well as its corresponding label, like what you can see. A text is there, the dataset of text, like the text can be this: the movie was amazing. So reading this particular thing, the system will understand that this particular statement is actually a positive statement. Okay, so the analysis after this particular statement would be resultant in the labeling of positive value. So that for that reason we need a data set, and as I said, in this particular video I am working on IMDB dataset, but I will show you other dataset as well which can be incorporated in BERT. So as we understood that the BERT follows bidirectional, that means it can read both from left to right, and it is a transformer whereby it needs the neural network for the implementation, and for that reason we are using PyTorch. Well, over here you could have used Google TensorFlow as well. That is also fine, not an issue. But since in this particular video I have focused on PyTorch, so for that reason I have installed the PyTorch and its associate libraries so that this can work pretty well. So these are the these are the packages that you need, and as you can see over here we have got sklearn to figure out that how much is the accuracy level, because as I said that BERT is under the natural language processing, but even if you talk about the earlier model like RNN, LSTM, they were basically working on the sequential part. But what makes BERT so special is that it can work from both left to right, and that's the reason why it is called bidirectional, right? And that's how the prediction over here is much more accurate compared to its previous models. Okay, fine. So I have downloaded a few things, and since I have downloaded already in my system, I don't want to download every time. So for that reason I have done some verification over here that if it is already downloaded, there is no point of downloading again. You straightforward move to the program, and here is my model which I am working on right now, the BERT token. This is the model in which we are going to work actually. So over here if you can see is that I have kept this particular code merged so that I'm still going to work on this. So for that reason, let me just take you directly to the code execution part of the program so that you understand that how exactly the thing is working. So let me run the code now, and here it goes. The name of the file is baseline.py. I hit the enter, and now the code is in front. I mean the execution. Yes, it's been already executed, and already I've downloaded the required files, as you can see over here. So it is reading those files from my system. Now it is asking for me to enter the sentence, and based on that it will come up with the probability. Well, I have already jotted down few sentences beforehand so that I can save time. So let me copy this particular statement, and let me put over here, and let's see what it does. It says that the movie had a slow start and the first half was not very engaging. However, the second half picked up the pace and became quite interesting. The climax was satisfying and the performance improved toward the end. Overall, it turned out to be a decent watch. So that's a complete paragraph I have given, and that's what the beauty of the BERT is like. In case of RNN or LSTM, when used to give a massive amount of data, it faced difficulties in remembering the context. But that problem is not there in context to BERT, because it maintains a neural network and it has got around 12 internal layers that will actually keep track of these particular sentences, so there will be no loss of information. I hit the enter now, and as I do that, the application reads the data and it comes up with the positive leveling, and the confidence level is 0.92. It's pretty high. That means very much confident that this particular paragraph is talking about some positive sentiment analysis. Okay, that's great, isn't it? So it's working really fine. So now let's pick up another paragraph from here, and let's see what happens. This time is that, let me copy this, let me come over here, let me paste it over here, and as I do that, okay, great. What it says, the movie had a decent storyline and the actor did a fair job. Some scenes were quite engaging and visually appealing, but overall it felt a bit slow and lacked excitement. It was not as good as I expected. Great. So it really understood that this is a negative confidence. Okay, the confidence level is negative, and it's just it is 50% confident that this is a negative statement. That's what it has put forward over here. Okay, I just gave a enter. That's the reason this particular statement came again over here. Just ignore this line. Okay, so overall this particular paragraph stated that the model feels that it's a negative, and the confidence level is put forward is like a 50%. It thinks that it's confident, because initially there was a moderate sign. The storyline had a decent storyline, actor did fair job, so there was a slight positivity, but gradually it became negative. For that reason, finally it came to the negative, and the confidence was almost 50%. Great. Okay, now let's book up this one. The movie was absolutely fantastic from the start to finish. The actor was brilliant, and the storyline kept me engaging throughout. Every scene was well executed, and the direction was outstanding, and I would highly recommend the movie to everyone. Great. So let me copy this. This entire paragraph is very positive, so let me put forward over here, and let's see what happened this time. And I hit the enter, and it says that yes, it's 95% confident that this is positive. That's what I said, that this paragraph is quite positive. So it has been able to figure out the positivity very smartly. Okay, now let's move on to this paragraph now. The movie started really well. I will come to this one, no worries. The movie started really well, and the performance was impressive. However, the movie started really well, and the performance was impressive. However, the storyline was terrible. The pacing was horrible. The end was extremely disappointing. It was very bad movie overall. See, very bad movie overall has been stated over here. The word bad will play a very important role. Okay, but let's talk about this paragraph now. The movie started really well and the performance was impressive, so this is a positive sign. The cinematography was beautiful and the music added a depth in the scene. That is also positive. Very good. So two sentences are in positive direction. However, the storyline became weak in the second half. Here slightly there is a downfall. The pacing slowed down and the ending was quite disappointing. Overall, it did not live up to the expectation. This line which I have added over here is actually a bit of dilemma. The grammatically, if you look over here, it's correct, but I mean the meaning is very you have to understand, the system has to understand that overall it did not live up to the expectations. The phrase over here is pretty challenging, and I'm not sure about how exactly this model is going to predict in context to this, because it has got a good positive starting point, and for that reason again there is a positivity, but it's very like it's not actually very sure about this one, because the reason why it has 50% confidence level. See over here, the positivity is just 50%, because as we can see over here, there's a gradually downfall was there. For that reason the confidence level it's saying it's positive, but it's not very sure. It's just 50% is saying it's positive. So confidence level is not that, but since the initial beginning was positive, so and there was a confusion by the model, because over here the last statement overall it did not live up to the expectation. This is a very meaningful statement, but it needs to have that level of IQ level for the model to figure out the meaning of this line, exactly what it means. So for that reason there was a dilemma in the model, and that's the reason why the positive confidence level is 50%. It's positive, it has stated, but it's not very sure. 50% is positive. That's what you'll figure out. But when we'll come to the last point, here it has been very clearly stated the movie started well and performance impressive. So almost the same thing what I mentioned over here. However, the storyline was terrible, the pacing was horrible and extremely disappointed, and it was bad. So many negative edges are there in the statement. So definitely I believe this will not give us positivity this time, rather it will give a negativity, and it has been 93% confident that this is a negative statement. Okay, so you understood that we can come across a more detailed statement over here in compared to RNN and compared to LSTM, which was not able to manage such a chunk of data, because there would be a lag of loss of information, but that didn't happen in case of BERT, because it is bidirectional and it is a transformer based. It has its own neural network, it has got 12 layers, so that means it can hold information for a pretty long time. As I said that I'm working on I gave the data set as IMDB, but it doesn't mean that it can only handle IMDB. You can go for finance, so for that reason you have to download this data set. If you go for medical, foreign data set, social, this one, and legal, this one. So there are different data set that has been provided by Google's BERT, so you can download them and you can work on them. Okay, that's really good. But one fine thing which I will be telling, which is very important for me to let you know, that I will be implementing domain adaptation, and or you can say it's a fine tuning. What domain adaptation is? Well, I will be using the IMDB or any of this as a base model. On top of that, we can implement the custom model as well. So that means I can combine two models simultaneously for getting a better result. Okay, because IMDB talks about only movie part, but suppose if I need to work on some finance stuff, I can use IMDB as a base model, and on top of that I can even train the finance data set as well, and that will give me more accurate result in context to finance. And that's what called domain adaptation or fine tuning, and that's what I will be subject of my discussion in the next video. But be sure about this, that the BERT is a far more better implementation of deep neural network in context to RNN or LSTM, because it's a transformer maze. So I would love to also come up with some more information about the execution of the transformer model, how exactly it has been very effective, because over here softmax and the softmax concepts are all going to be implemented over here as well. In fact, it is already been done over here, but I would like to highlight them in more details in the upcoming videos. So you can consider that this is a basic video where you saw that how exactly the BERT is actually working in picture, and for that reason I have implemented all the recommended libraries which are required to work the BERT application. And as I said, I will be working on the next video where domain adaptation would be my topic of discussion. Okay, I hope that this video will be helpful for you all. See you soon. Bye bye.